All right, you're welcome to Project 500. And just like our advert has already introduced the project, many questions are going to be solved. All right, at least up to 500 past questions upwards with reference to university entry examinations. Here we have one of the first question we want to look at here is taken from mechanics, and we have velocity time graph. Okay, so this velocity time graph is a picture of the movement of a body that accelerated from a point and then it ends the journey with a certain retardation. So the question says, diagram above shows velocity time graph. Its acceleration and retardation respectively are, so they want us to determine the acceleration and the deceleration, looking at the graph of the motion above. All right, here is the problem before us. The acceleration is along this side, all right? And then the retardation occurs along this side. Retardation is the opposite of acceleration. So we have them like that. So the first thing we have to do is to find the value of this acceleration. Okay, so from 0 to 20 degrees, the body accelerates, right? So the time frame of acceleration is from 0 to 20 degrees, all right? And the maximum velocity it attained is 80 meters per second, as you can see in the graph, all right? So the maximum velocity, which is the final velocity, is equal to 80 meters per second. Acceleration is what we want to find. The time frame within this acceleration is 20 seconds. Of course, because it begins from rest, initial velocity is equal to 0. So if we have, in stage 1, if you have all of these parameters, what equations of motion will be prescribed to be used? We have final velocity, we have acceleration is to be determined, our time is 20 seconds, and then initial velocity for a body moving from rest is equal to 0. So we will have to use our V. Our V is equal to U plus 80. So for this reason now, our V, which is 80 meters plus 0, then we have A times 20. So what it means is that we have 80 is equal to 20A. Therefore, our A is equal to 80 over 20, which is equal to 4.0 meters per second. So that's the value of the acceleration. Now, the retardation begins from this point down to the point of equilibrium, or the 0 point in the graph. So along this side, the time frame, which is along the time, is 90 minus 50. That's going to give us 40 seconds along this side. So we have 40 seconds. So we now say that the time, now the body is coming to rest. So there's a transformation of velocity here. So at the points where the brakes are applied, at this point, the final velocity now turns to initial velocity. So the value that we used as for final velocity becomes the value of U. All right, so there's a swap of velocity at this point. V now becomes 0, and then what used to be for V becomes for U. So in that wise, our time frame along this side is equal to 40 seconds. And then our final velocity is equal to 0. Our initial velocity now is equal to 20, is equal to 80 meters per second. Then the deceleration is what we want to find. Still, we use this formula. V equals U plus 80, all right? When we substitute, what it means is that we have 0 is equal to 80 plus the time frame is 40, so we have 40 times A. A is now our retardation. So we bring it here. What it means is that we have 40A is equal to 80. And therefore, our A, sorry, that's going to give us minus 80, because if you bring 80 to the other side, so if we make A the subject, what we are going to have will be 80 divided by 40, and the result is equal to 2.0 meters per second squared. So if you look at the options, check for the option that says we have 4.0 meters per second squared and then 2.0 meters per second squared. So any option that carries this pair of values is therefore the correct option for this UTME question. I hope you learned something.